they send us some handouts too. It's about 2 or 3 handouts we get as well too.
Handouts are what was the topics that you all went through with Dr. Legion on Saturday?
The water treatment system and treatment methods.
The water treatment system and what was the other
Methods.
topic?
Methods.
Method. Okay, so what problems are you all having? So here we come again. Another new set of topics being done, right? And we come to tutorial to discuss the topics that you all have trouble with, because there are students struggling, and tutorials is something that's supposed to be helping you guys. So if it's something wrong that I'm doing, please tell me so I will understand. If it's something with the teaching method, if you all need more help, if anybody need more assistance, you can tell me. I am not a beast.
Sarah, I just want to ask how we structure in the essay exam, please. So I could start to work on it.
You structure your essay in paragraph form, so you speak about your points. So you all did the water system. I know some people would have been practicing structuring that into an essay, right? Now, the water system is not a lot to remember, right? So I just say you can learn it in a flow chart, and when we do the water system, we start from when the rain falls, right? And the water is collected by WASA, right? And it goes through the filtration process of, anybody can tell me how that filtration process goes, right? We'll be discussing that, because that's the beginning of that's the beginning of the essay. And after you speak about what it goes through with in WASA, excuse.
Rosa, I'm come and bring my charger. Why does you so not to charge my phone? Oh, nice.
Okay,
Oh,
you could.
shucks.
Yes, your mic is on.
It'll start from the rainfall, then it'll be collected into the how did the water treatment. I have a lot of knowledge. It'll pass through from the reservoir, it collects into the reservoir. From the reservoir it goes into the treatment where it is it just had to go through the different strainers. From the strainers it will go through the filtration, and after the filtration go be where it is they're gonna neutralize the organisms and them.
Yes,
From
right. But
that, yeah.
so did you all go through that process? That is my question. Did you all go through that process?
Yes, Miss Dr. Leisure, explain
Yes,
that.
miss.
Okay, right. So when you I just wanted, before we continue along that topic, I just want to finish the answer to the person that was asking how you write go along writing the essay. So that's how you will start, right? And then you will continue by talking about how when the water goes from WASA to the dialysis center, right? So that would be like a second paragraph. So your first paragraph is about what happens at WASA. Your second paragraph will be containing what happens at the dialysis center, where it goes through the multimedia, the softener, we softener with the brine tank, the carbon one, carbon two, right? The arrow, right? And then it just goes. Then your third paragraph will be when it goes to the machine that is through the direct or indirect feed, right? And that is just it for your water treatment. So water treatment is not had Kadira, your hand is raised.
Yes, miss. Not to cut you across, but I joined when you were asking if there's something that you could do to help us. And our group was actually discussing like if we could get tutorials more than once for the week, at least twice for the week. That would
Oh,
be
well,
nice.
it has always been that tutorials is once for the week, but that's why I am available all week, right? So if you want to contact me for information, you can.
Okay, miss.
You understand what I'm saying, right?
Yes, miss.
So if you and your group doing a study session, right, and you want to call me, no problem.
Okay.
You have a little Zoom session or a plan. You could message me like the day before if you want, and say, well, okay, yeah, may start having a study session. We having a study session. They say Wednesday night, probably 7 o'clock. You don't have time. Probably yeah. Okay, cool, no problem, right?
We actually
And
did a study session last night, but it started at 8, which should be too
okay.
late for you.
Yes, but this is what I say. We can work around things. That's the whole point of speaking to someone. How would you know someone if you don't speak to them or if you don't have any contact with them? It's better than just sitting there and guessing because it had a student tell me, she said, Miss, is so much of us that you have to deal with. Is this the first class that I am dealing with? No. This is my job to deal with students. My last class had 102 students, and in my tutorial, I had 85 of them. This is my job. I'm accustomed with this. I can't deal with this. So if you call and you ask me, well, miss, okay, we need help with this. You understand? I say whether I'm available or I'm not. But how would you know if I will be available if you do not ask me? I had a
Understood.
student. I had a student. She understood me so good that it had a night I sleeping and 2 o'clock in the morning. This girl and her group they was having a study session. Now I'm not saying that call me 2 o'clock in the morning, but I just showing you. She was so confident that she would get you with me. Celine was her name. She wake me up. You understand? 2 o'clock in the morning, miss. We having a study session. We want to find out this question and asking me. No, I was vexed, but you know. I went back to sleep after because then I had to go back to sleep. But the point is that's to show you how far I go for students. Because I really want to see how they pass. When students pass, it does make me look good. When are they not passing, right? It's not making me look good and I'm not feeling good. Because I feel like if I'm not doing my job and I'm not doing the most that I could do to help, and I know I'm here to help. So I just want to feel comfortable to know that I will help. So moving on. Yes. So somebody can tell me the process of the what goes on in WASA.
Let's see. We also collect the water from the rainfall, which is the surface water. It
Yes.
goes to a dam, then they treat it with chlorine, then it's sent to we tap.
Yes, yes. Yes, okay, I reopened the group chat. Let me see. Missions. Yeah. So yes, you're somewhat correct, but between there are steps, right? So anybody else would like to tell me what happens with the water with water before it reaches to our tanks and our kitchens and in our pipes?
But I didn't even study that.
Yes, how to be treated.
Yeah, the water is, but you have to talk about how it is treated. So I I
With
will
the chlorine and the
I would like to I
chlorine.
will just say give you all the steps. It goes through coagulation, fluctuation, sedimentation, filtration, then disinfection and fluoride, right? But
Miss Sarah, just call it over now, writing.
yes, I am going to call it over, but I am going to do it step by step, right? And say what it is. I will So before I explain the steps, let me call it over, right? It goes through coagulation and flocculation. Coagulation, coagulation and flocculation. Flocculation. So when the rain falls, before you all start writing, what is coagulation and fluctuation, right? When the rain, when you right, when the rain falls and it flows down the hills, it is collected into into a lake or a reservoir, right? And we have to ensure that this water is safe to drink. So the water is tested and treated with several steps. And these steps include, now I'm not reading from something that I wrote down, but I will still reading it out for you all, and I will do up something and send it like a flowchart for you guys. Okay? For the ones who missed out on it. So coagulation and fluctuation, we understand that dirt and dissolved particles, they have a negative charge. So they add a chemical called alum, which is an aluminum compound. This has a positive charge, right? So it is added to the water in this first step. This is the first step of treatment, right? So alum is added to the water, right? And these neutralize the charge. And by neutralizing the charge, right, the dirt does bind. You understand? Which is coagulate. So the dirt does bind, open brackets, coagulate, close brackets, with particles to form something called a floc. FLOC. So it forms clumps or a flock, right? And that's why I call it coagulation and flocculation, right? So I'm going to repeat that. Everybody hearing me clearly?
Yeah.
Yes, ma'am. Yes, miss.
Yes, miss.
Okay, everybody understand what I just said?
But study over it.
Yes,
Slowly.
I'm going to say it over. Now it might not be my same words every time, but it's the same thing, right?
Yeah.
Because remember, I don't have this right down. I'm telling you, right?
So,
Yes, miss, excuse, you could check the waiting room.
Yes, I have nobody in the waiting room. I've admitted all students in the waiting room.
There are 3 students that
The last person
waiting.
admitted was Sarah Hussein, I think, and have nobody
Okay.
else in the waiting room.
I tell them to come out and go back in and see.
Okay, so I was okay. So yeah, look one here. Sorry, Sha. Okay, yeah. So when the rain falls, this water is collected into lakes or reservoirs, right? And this water has dirt. Everybody can mute your mics, please. Thank you. Right. So this water have dirt and dissolved particles, right? And dirt and dissolved particles carry a negative charge. Okay, just hold 1 minute. I have a student here that needs a link. Yes, so dirt and particles has a negative charge, right? But in order to get out these dirt and these particles, we have to go through a filtration process, right? So they add a chemical called alum, which is an aluminum compound, right? They add this to the water that they collect, and this alum, it has a positive charge. So positive and negative neutralizes, right? And what it do is that when it neutralizes, it binds together, right? So the positive and the negative charge, it binds together, right? And it coagulates, right? So the binds is coagulate, binds, open bracket, close bracket, coagulates, right? So it coagulates with the particles to form a large clump or a flock. So when these particles come together, right, it's called a flock, FLOC, right? And it is called this process is called flocculation. So alum is added to the water, right? And the negative and the positive charges mix together and it binds or coagulates. And this coagulation, right, form together a clump or a flock, right? And this is called flocculation. Alum is called a flocculant for this reason, because when the alum gets thrown into the water with the dirt, right, the positive charge that it has mixes with the negative charge, right, and it coagulates, makes it clump up together, right, and by clumping up together, it starts to make this flock. The clumps is called flocks, right, and it fluctuates. So that's why they call it coagulation and flocculation, right? So the first step was coagulation and flocculation, right? So when these clumps start to form and it flocculates, next we have the sedimentation stage, right? Because when the particles by itself, remember, it light, but when it come together, it will become heavy, right? So this is the sedimentation phase where the heavy clumps settle to the bottom of the water, right? Because it has flocculated. Everybody with me on that?
Yes, miss.
Nice. Right? And
You repeat?
in the sedimentation stage, the heavy clumps settle to the bottom of the water. Next, we have filtration, where the clear water on top of the sediment is passed through a series of filters, right? And so that is to remove the dissolved particles, right? So it gets passed through a filtration process where it removes the dissolved particles. And then the water is disinfected, right? And this is when chlorine or chloramine is added to the water.
Miss, you could just go back through sedimentation.
Okay. So after coagulation and flocculation, where the dirt mixed with the alum, right, and it binds and coagulates, it forms particles. The particles form together, causing a flock, right, and it flocculates, right, and then the heavy clumps settle to the bottom of the water, and this process is called sedimentation. sedimentation. So this process is called sedimentation. And when the clumps settle to the bottom of the water, right? The clear water on top of the sediment is passed through a series of filtration. So this is the third step here, filtration, right? So it passes through a series of filtration or a series of filters to remove the dissolved particles. And then the water goes,
Excuse me, so you could check and see if anybody else, you seen anybody else?
The or it mark joining. It have Ariana in the waiting. It mark joining.
Tiana trying to get in and she's not getting in.
I sent her the link. I sent her the link on WhatsApp.
I don't know why
Tiwana?
she. Yeah.
I sent
got
her the
you.
link. I know. Okay. So
Thank
she's
you.
here. You're welcome. Right. Nice. Yes. So then when the water goes through the filtration process and the particles is removed, right? It then goes through a disinfection process, and that disinfection process is simply when they add the chlorine or the chloramine to the water, right? If anybody knows what chloramine are made by, so chloramine is chlorine and ammonia, right? So they either add chlorine or chloramine, right, to the water. And what this does is this is to kill any microbes and parasites, right? Some in some places they also after they add the chlorine, they put fluoride in the water also so to prevent your teeth from rotting, from tooth decay, right? So I was just mentioning that. So this is when the water gets sent out into the taps and we get it. And the dialysis center gets it. So when the dialysis center collects this water, anybody wants to tell me what happens there when the dialysis center collects this water, because you all didn't know what happened in Wassa. So I tell you all what happened in Wassa. From when the rain falls to when the water gets collected in the reservoir until it reaches the tap. Everybody understand? Everybody have that down?
It's not everything, right? Because you're talking real fast.
I repeated it 3 times. And what I also said is that I will
Yeah.
do a flow chart, right? And send it to you guys. Which no, I don't know how you all didn't get this, but if no, it was Dr. Legion who taught you also. I understand she probably didn't go through this whole process, but usually Mr. Wazir and Dr. Michael goes through it like this, from when the rain falls to the water plant, the sedimentation, the fluctuation, the coagulation, right? And for the ones that said I'm speaking too fast, let me just go through the points one by one, just the points, right? First, we have coagulation and flocculation. Then we have sedimentation. Then we have filtration. Then disinfection. So you could dash them, and you could put next to coagulation and flocculation. We have the dirt, binding together with the alum due to the dirt having a negative charge and the alum having a positive charge, right? And it coagulates into large particles, and these large particles are called flux. So flocculation takes place. Next to sedimentation is where you have the heavy clumps is when the heavy clumps settle to the bottom of the water. For filtration, the water is filtered goes through a series of filtration, right? Or the water goes through a series of filters, right? To remove the dissolved particles. And then we have disinfection. Next to disinfection disinfection, chlorine or chloramine is added to the water. Then it is sent out to the pipes. But we cannot use this pipe water and dialyze patients, right? Because although it is filtered, it has chlorine in it, right? And it's your blood you're dealing with. You understand? So it have dialysis standards, right? And dialysis water standards is not primary drinking water standards. You understand? Example, the chlorine, the chloramine in drinking water, it could go up to 4, right? 4 milligrams per liter. But the chloramines in dialysis water, it could only stand a chance to be at 0.1, right? The calcium in drinking water, it don't have a standard, but the calcium in dialysis water, it could only go up to 2 milli equivalent per liter, which is a very little bit. You understand? So another thing, when the remember alum is an aluminum, right? And in drinking water, it don't have a mandatory standard for the amount of aluminum in drinking water, but the amount of aluminum in dialysis water, it could only be allowable 0.01 milligrams per liter. So this water have to be filtered, go through a really good filtration process, right? So anybody want to tell me when it reaches to the dialysis center, what is the process that this water goes through?
Must I have the backflow prevention device first?
Yeah.
A pre-treatment.
And then I had the booster pump.
Yeah. And then no, yes.
And then I have the
Pre-treatment.
filtration.
Yeah. I'm listening.
And then I have the softener, the brine tank.
Yeah.
Then the
And
carbon
then the
filter.
carbon filter.
And it goes through purification. And
That is the
reverse.
end of the pre-treatment phase.
Reverse.
And then to osmosis, reverse osmosis.
Mm-hmm. Then it either
The
deionizer
deionizer.
is a optional, I believe.
Yes.
And then it all UV, the
The UV
ultraviolet
light.
exposure, UV light, yeah.
Yep.
Okay. So we have the steps, right? But we still need to explain them a little bit, right? So the person that Sammy that was just talking, let's say she said that you started from the backflow prevention device, right? So we have, right, but before that we have the blending valve, right? I know,
That is the
I
same as
don't
the
know.
temperature, the one
I
that
shocked,
regulating the temperature.
yes, I shocked that you all actually have actually went through it. So that's good, because it's helping me a lot. So we have the incoming water, which is in the pipe, right? This is the basis of the dialysis water, right? And it coming in cold hot, however, I don't know. So we have the blending valve, which mixes the hot and the cold water, right? It mixes the hot and the cold water to a standard temperature, and the standard temperature is around 77 degrees Fahrenheit. I just giving an approximate, right? And after the blending valve, we have the backflow prevention device. Somebody could tell me what this backflow prevention device does? I don't want to say it.
Miss, the black backflow prevention device is
Yeah.
crucial to hemodialysis facilities to protect both the potable water supply and the dialysis patients from contamination. A reduced pressure backflow prevention is commonly used at the inlet of the of the pure water treatment system to isolate it from the rest of the potable water system. This prevents black backflow of potentially contaminated water from the dialysis system back into the potable water supply.
Oh my God, like that was so good. Like, yeah, because
Miss, I have things to add to
it's
that
the same. No,
too.
it is correct, right? But that is so much explanation just for
Yeah,
a backflow prevention device, and I give you a kudos for that because all I would have said is that it
they
keeps
talk
treated
about
dialysis water from
the
backing up
backflow
into the tap water system.
and the backflow of disinfectants too into the building's main water supply.
Yeah, so yeah. So the backflow prevention device, it keeps treated dialysis water from backing up into the tap water system. For those that can't remember the whole and the set of explanation, right? I just try to break down things as much as possible. So next, what we have after the backflow prevention device?
We want to get more than 1 point this time in the essay.
Well,
The booster pump.
wait, now somebody says I thought they want to get more than 1 point in the essay, but I know I went through essays, right? And I also saw the papers that Dr. Michael corrected, and I saw some people write 4 lines, which is many. People just write 4 lines, and I sure I didn't even teach that, especially out of my students that come to my tutorial. So even though,
Miss, we freeze.
excuse.
I say I think we froze on that day.
No, no, it have nothing like freezing because it have no fridge, right? And it have no freezer. So it have nothing like freezing. It's a matter, you just take your time. It have nothing to fear. You have your paper, you don't have your answer in your head, and you write. Like, are they just afraid to write? Write. It's have nothing like writing too much, right? I get Dr. Michael to push the hours from 3.5 to 4 hours. Just for a little hard time. Because some students were saying that they don't have enough time for the essays or whatnot, but I was saying that I don't have time yet. Still, half hour coming out of the exam. By the time I want, I have 2 hours, and the papers, and them still end right up. So yes, I am breaking it down, but yet still I have the most important points that you all need to have. And once mentioned, sure, you're getting a point. And it's not 1 point, but you're getting a point for each point, which makes up the whole 10 points for the question. Because everything I come to this tutorial with, or to my tutorials with, I go through it with Dr. Michael. Every single thing. So I don't ever come here without going through something with Dr. Michael and speaking to him about it. Not because that I am unsure, but because I want him to know what I am teaching you all also. So yes, there's a big long explanation for the backflow prevention device, but not everybody can remember it. So to the ones that cannot, I would just like a shorter explanation for it, is that the backflow prevention device keeps treated dialysis water from backing up into the tap water system. If you all want to continue and add on more, no problem. And what comes after the backflow prevention device? Anyone would like to tell me?
Booster pump.
And what the booster pump does? Yes, the booster pumps, it is keep water pressure consistent, so the RO system has a consistent flow. So the booster pump keeps water pressure consistent, so the RO system has a constant flow.
The arrow system.
Yes. The reason why they say RO system, remember, it's going through the is one pressure. You need to go through the whole system. You understand? Because from the between the steps, it still have a pressure that go in. It's nothing like it's settling, it go in.
And it prevents multiplication of bacteria too in the system.
Yes, because
Prevents.
because it continuously working.
Miss,
And
excuse how much PSI it is
I don't know I don't know. It does mark on the arm. Well, when you're turning on the water,
mm-hmm.
it does mark. It does mark upon the
All the
machine.
smart all that is smarted miss. I was to
Yeah.
ask miss as you say concerning the prevention for the backflow thing, right? Miss, I know it as a check valve, and I had asked Dr. Michael about that tomorrow.
Yes, it is. Yes, it is. But remember, this is American words, so that's what
Mm-hmm.
it is called. It's American standards, and on the place chart, that is what it is put. Backflow prevention, right?
And that is just
So
simple
that
that check valve because it's either PVC or brass in the miss. That's what I was
yeah.
saying to myself because I was watching it.
No,
I was watching it the other time.
It does be PVC, but it's a special type of piping that is used also.
That might be schedule 80. Maybe
I
schedule
don't know,
80.
Donovan. But I'm glad you must know because you're a plumber. And I
Yeah,
remember that.
yeah.
Yes, so after the booster pump, what do we have?
The
The
depth filter.
multimedia filter.
Yes, the multimedia tank. And how much layers it has?
3.
5. The first one, I think it has is gravel, granite 12, granite 13, sand, some type of sand and anti-type, but just now I'll get it. But it's 5 layers in the multimedia tank.
Upper distributor, speedboard, um, anthracite,
Yes,
filter
anthracite,
sand,
yes, sand, granite and gravel.
granite. Let's see. I ain't seen the gravel. I seen
The first layer is gravel. It has
underneath.
gravel, then granite. There's 2 layers of garnet, sorry.
Must
Right? So
excuse. You know, we
yes.
forgot something. I believe this here the temperature mixing valve. I believe
No,
is
that was the first. That's the blending
That was
valve.
at the
That's the
beginning.
first valve.
alright.
So
Just making sure now.
Donovan, you're off. Wait. Let me start over. Incoming water from the taps, right?
Right.
Into the blending valve, which is the valve that mixes the hot and cold water to reach a standard temperature, right? Which is around 77 degrees Fahrenheit. Then we have the backflow prevention device, right? Which keeps the dialysis water from backing up into the tap water system. Next, we have the booster pump that keeps the pressure consistent so the RO system has a consistent flow. Then we have it goes to the multimedia tank where there are 5 layers of filtration, which is gravel, garnet, I think it's garnet number 12 and garnet number 13, but I will find the number, but it has 2 layers of garnet. There's a sand layer and an anthracite layer. So it has 5 layers in the multimedia tank. And yes, you will get marks for naming the full 5 layers in the multimedia tank. And if you don't name it, you'll be losing a mark. So after the multimedia tank, what do we have?
A carbon tank, miss.
No,
Softener, miss?
Softener.
Softener.
Yes. So we have the water softener, but what the water softener tank does come with?
Brine,
Nice. And what it has in the brine tank?
resin beads.
Salt, resin beads, and
Oh
salt,
no,
sodium.
and
Sodium.
sodium
Sodium.
is sodium.
So that's the same salt we put in the food every day. It just had the brine tank and just be full up of salt. Right? But what does the water softener do?
It softens the
It
hard
coats
water.
fluid. Coats fluid.
It
Yes,
removes calcium and magnesium.
yes, it removes minerals because remember when the rain falls, it does have
Yeah.
limestones in the water and these kind of stuff, right? So it is the water. Then remember the water never take these stuff out of the water. You understand? So the drinking water come in with calcium, beryllium, cadmium, antimony, aluminum, potassium, sodium, sulfate, thallium, right? I just saying things that the drinking water have. So these are the minerals of the water. So the water softener removes the minerals from the water, right? That's what the water softener together with the brine tank does do, and it does make the water softer. And after the water softener, what do we have?
Then we had the carbon tank.
Nice. Carbon. And how much carbon tanks we have? 4 and
2.
Two
2?
miss.
Okay.
Two.
So
Yeah, the
okay.
The
worker
worker
tank and
and
the
the
polisher tank.
Polisher.
Okay, I thought we had 4, but nice. Nice to know that I know. Yeah. So, and what does the carbon tank do?
It removes chlorine
Rem-
and sorry.
chloramines.
Yes, it removes chlorine and chloramines. So the both carbon tank doesn't do the same thing, it do different things, and
Yes.
It removes it
Yes.
does the
Double
same
check.
thing.
no, it does do the same thing. It doesn't do
Yeah.
different things. It does do the same thing. So if carbon tank number 1 didn't remove all the chlorine or the chloramine, it goes to carbon tank number 2, which it goes through a second chlorine removal process, right? Nice.
Yeah, so
And
that's why they just
after,
call it a backup tank.
yeah, a primary carbon tank and a secondary carbon tank. If you don't want to call it number 1 and number 2. And then we have what next?
Reverse
Reverse osmosis, yeah.
Okay, so right. Okay, so sometimes they put a cartridge filter before the arrow to catch any carbon fines or resin beads, any debris and particles that could damage the arrow, right? So right after the carbon tank, it have the cartridge filter. Just mentioning it, right? And yes, we have the reverse osmosis pump. And what does this do?
Miss, this removes impurities, including salts, bacteria, and endotoxins.
Yes, but
It does
how?
have a permeable membrane.
By
It says movement of concentrated water, which is forced to flow in the opposite direction, opposite to osmosis, across a semi-permeable membrane by means of high pressure, which produces purified water.
Yes, yes, yes. That is it, Kadira. It's yes. It increases the water pressure across the air membrane, right? And that is great. And after the reverse osmosis pump pushes the water to the air membranes, what happens next?
the deionization system.
Yes. So you have a deionizer, right?
But
And what
excuse
this the
me, so
deionizer does?
that not optional.
Yes,
I think she mentioned that not everybody does use that
yes,
system.
yes, but we still need to know what the deionizer do. Does. It don't matter if it's optional in dialysis centers. See if you get 100 on the paper and Dr. Michael find you get 100 and see if you're looking to see right that deionized and get 99. No, that type of way. So it's good to mention these things because it's important also. And that is actually the proper system by the American standards. I think that's called the
What
ANSI standards. So we have so what does the deionizer do?
It further purifies water after reverse osmosis, ensuring it's free of ions and other contaminants.
Right. And then it goes to UV light. Right? But now the reason why there's some centers that does not put the deionizer, right? After the iron membrane is because after this water don't go through all this hydrostatic pressure, right? And this filtration, you put in a deionizer that's going to kill endotoxins. When endotoxins die, where are they going? And these are microbes too. So that is the reason why not all dialysis centers does use the deionizer. Because when the endotoxins or whatever it die, where will it go? Because they're not going through an exfiltration process, through an RO. You understand? Everybody understand that?
Yeah, miss.
Because
Yes,
because
yes.
from that, then it going straight to the patient, you know? So how this water going to the patient now after it goes through the system?
The distribution system, a
And
network of
what is
pipes. Oh,
excuse?
sorry. It's a
What is it?
network of pipes and fittings that transport purified water to dialysis machines and return the treated water.
Yes, but what it is? How does the water go to patients? True, there are two types of feed.
Distribution,
So the
direct and
water is
indirect.
distributed to the patients, yes, through pipes and fittings, but it's not that you want to mention. You want to mention that the water goes to the patients through
Indirect and
two that
direct.
yes, through two different types of feed. Did you all do direct and indirect feed?
Yes, miss.
Right. So somebody could tell me what is direct feed?
Miss Daisy, distribution system.
Yes.
Yeah, advantage of direct is dialysis is used right away.
No.
So the
No,
chances
stop. Wait. We are not talking about advantages, and this is how people just go in the exam room and get a question wrong because that was not the question I asked. The question was, what is direct feed? Explain direct feed.
Is when the water after purified is used directly in dialysis.
Okay. Anybody else? And so,
Is
and
delivery of the treated water without recontamination.
yeah, but how does it how does direct feed work?
Directly.
Okay, so from the arrow system, right? Direct feed
It
works
doesn't.
like this. From the
Mm-hmm.
arrow system, it goes, yes, it goes directly to the machine, right? To the machine, to the patient, whatever water is used, right? And then the unused water goes straight back from the through the arrow, right? And so it continues to go in that cycle and just keeps getting purer. So the unused water goes straight back to the arrow and it just continues passing through the arrow and getting purer and going back to the machines, right? And whatever it uses, it goes to a separate drain, right? But whatever is unused, it just continues to pass through the arrow. So that is direct feed. And everybody understand what is direct
Just
feed now?
no, I don't understand the direct speed. Could you just go over one more time, please?
Yes, go
Okay,
over.
Miss,
so
I
we
can
go in,
explain it.
huh?
Miss, I can explain it.
Donovan, you could go ahead, take a try. Go
I'm
ahead.
gonna try and explain it for letter understand, right? All is basically these two connections, right? One is the direct connection from the main, which is direct, and indirect would be like supplies that coming from the tanks now. Son, that is the difference here with direct and indirect feed now. So a direct is like
The
how
wait, hold on, Donovan. The direct is what? Is from the main and what?
direct is direct WhatsApp connection, and indirect is
No,
that's
no,
coming.
Donovan.
No, miss.
Donovan, no.
Let me see what Google say here because I see
No,
something on the internet.
direct feed in this is not have nothing to do with WhatsApp. This has to do direct and indirect feed is how the is two different methods in which dialysis centers distribute the water from the arrow system.
Mm-hmm.
So let me go it over again. From the arrow, the water goes to the machines, right? And what the machine it have as so it's like a straight pipe. I want to try to share my screen now. I can't draw all that good, but I have my paint chart up here just now, right? And we are going to be drawing together. Everybody seeing my just in this so we could scrap, right?
Yes, ma'am.
Yeah. Let me see. So we have the arrow here at the beginning, right? And right. So okay, how does draw with this thing brush, whatever. Right. So your arrow starting here, right? And by these little lines is where your machines is connected, right? So your machines, these lines is where your machines connected, right? So direct feed from your arrow, it go in here. So this is your main water stream, right? And wherever the machine using, it's using. So it pulling from the water, right? And the unused water just keeps going back, and then it will go around the arrow. You understand? And I'm going straight back. Wait, let me see if I can get a curve in this and do that. So, how
I
is
think
it?
you like the correct thing. You have to draw the line and then curve it from the
Okay,
center.
so I was doing the correct thing, right? Okay.
Yeah.
So it is coming here, right? And okay, so let me try to do it. And it's going around. Nice. So come back. Oh God, wait. Okay. So come back to the arrow, right? Which is like right here. I'm making a straight line here because I'm not good at this. But I just want you all to get concept. As I said, I am going to do a flow chart on this, right? Right. So it's starting here by the arrow. How you can get okay, a pencil here. So you're starting here by the arrow, right? So this here
So
is your
the
arrow.
arrow representing the water coming from the tap.
No, the arrow representing after you done pass through your multimedia tank, your softener tank, your carbon tank, your
Okay.
purified water, not your tap
All
water,
right.
right?
Okay.
Yeah, miss, this
So
is after the process. They just go
yes,
going on with the
this
traveling
is
of the
how
water.
yes, so this is how the water is distributed after it goes through the purification process. So we have this here, which is your arrow, and the water coming from your arrow, and it coming to machine number 1 using water, then come machine number 2 using water, then it come machine number 3 and using water, right? But the unused water, it comes straight back to the arrow system, which is here. Everybody understand now?
Yes,
What
miss, and
is
the
direct
process
feed?
keep going on. and going on again.
Yes, and
Understand?
so when it come back to the arrow, it just going back straight through here. The machine continue taking whatever water and it going straight back around and go. So it just continue to go into that cycle. Understand?
Yeah, miss. And the
Right.
So it's
So
indirect.
recycling.
yes, it's like it recycling over and over. So that's the
Recycling.
direct feed.
Yeah.
Yes. Yes. So that's how it is. But with the indirect feed now, right? We have,
A holding tank.
yes, you hold it. Yeah, that's what I mean. Let's get this thing. Use here. Right. So
Somebody.
yeah, it have a tank here. You understand? Now I just draw this one square
Mm-hmm.
because I want to think. So and your arrow down here, right? So this is a machine on this end here. This is a machine on this end here, right? And you have machines, right? So from your arrow, it goes to the machines, right? And then it goes to a tank and it is stored. And then back to it, then the unused water goes into a tank and it is stored, right? And then it goes back to the arrow and then so it's like indirect feed. It's the water being stored in a tank first before it goes back through the arrow. So you understand the difference? This one have no tank, but this one have a tank.
Yeah, miss, it's like, maybe they don't explain it fully, but it's like more or less the same thing. As in terms of the supply, like how to go through the
Yes.
filtration. Yeah, no, but yeah, it's more or less the same thing in a way.
So it goes everybody understand indirect and direct feed. So after the arrow system, the method of distribution is indirect feed. Indirect feed, this is where the water goes straight to the machines and the unused water goes back through the arrow, right? And the indirect feed is when the water goes from the arrow membrane to the machines and it is stored into a tank before used again.
Miss, this happens at the same time or is it two different
It
processes? So
is
the
two
direct
different,
goes.
it is two different methods. Our dialysis center, right? IME uses a direct feed system because it is the better system because you're not storing any water to collect any kind of microbes, right? So we use the direct feed system, right? And it comes, somebody says direct feed means the purified water from the remote osmosis. Okay. From the reverse osmosis unit in a tank before it is pumped to the distribution. Yes. Yes, so Sarah Ramkran, direct feed means the purified water from the reverse osmosis unit is, oh my God, I was reading that for everybody, is directly sent to the distribution loop and then to the dialysis machines. Indirect feed involves storing the purified water from the arrow unit in a tank before it is pumped to the distribution loop. Yes, and that is correct. So it is which method the dialysis center chooses to use. Some dialysis centers uses the one with the storage tank because sometimes, not all the time it does have water in the pipe, or yeah, and try to just help them conserve water too, right? So although you have your backup tanks, you still have your tank for your indirect feed.
Miss, you take off your joint.
Yes, because it wasn't really a joint. And I said I'm going to do a whole um thing for you guys properly, a flow chart, so it will help with short meanings, you know. So everybody understand the water system.
Yes, Miss.
So we
Yes,
could go through the
Miss.
whole thing point by point, right? So we start from when rain falls. We have coagulation and flocculation, then sedimentation, next filtration, then disinfection, and then the water goes to the dialysis center, right? And this incoming water goes through a blending valve. What mixes the hot and cold water, so it goes through the blending valve, then the backflow prevention device, then the booster pump, then the multimedia filter tank, then the water softener together with the brine tank, then the carbon tanks, which is 2 carbon tanks, number 1 and number 2, a primary and secondary carbon tank. Then the cartridge filter to the reverse osmosis pump, to the reverse osmosis membrane, next to the deionizers and the UV lights. And from there, through an indirect or direct feed system. So you have all your points, and all you have to do is just say a little bit on what everything is, and you have a little 10 points question. Everybody understand?
Yes, Miss.
yes, miss.
So anybody, oh my god, anybody have any concerns right now about the water system? Because when we go through this week, right, we are not coming back to it next week. Next week we are doing a new topic, because you all still have to go through dialyzers and was that iron and them kind of thing, and was that acid and base and this kind of stuff. You all read all the handout?
I
Apparently,
read
I'm
them,
talking to
eh?
myself.
I
Slowly
don't
but
know.
surely.
I have to
Same.
learn it. You see, all them definitions. Where's that acid? Where's that base? Where's neutral? Is pH? Where's that iron? Them kind of thing. What you know? You have to know these things. So reading the handout and figuring and seeing if you could remember the meanings will be helpful. Yes, Stephanie was going to speak.
Yes, I was. Good night. I know I joined late, but tell me now what essays it is we have to do. I know the water system, like what we just normally do for you now, the water system, and what else?
That's all for that's all that I have right now. The water
That's the
system, yes,
water
please.
system.
I want to make sure that everybody, you all have it done pack, and I hope that the ones that don't get it, if you all need help, still message me, and I am going to do a flow chart on the water system, which, you know, and you all didn't get a handout on the water system. I didn't get a handout on the water system from the school.
Yes, we did.
Yes, we did.
I would like to see that handout. Somebody could send it to me. I didn't see it.
And I think even in the textbook, the review of
Yeah, the textbook have
hemodialysis,
it.
it yeah, it's have it.
But I don't use one hemodialysis textbook. I have others, like 2 others, beside the 2 that you all have. Yeah. So I got when I gather my information, I make sure everything corresponding and stuff like that. Because it have more information. It have more to just that book, you know? So what other problems do you all have? So everybody good.
Miss, all it is that I had to that I didn't run through properly when it comes to the water is the effects of the contaminants, which Dr. Alicia said we should learn.
Yeah.
And our next table, the processes and the contaminants removed. Yeah, I think that is it.
So what is the effects of not purifying dialysis water?
It could what do you mean? Like if you can't just use the water from Wasa, because I think Dr. Alicia was saying that it could be fatal to the dialysis patients.
Yes, because it have chlorine. Remember, that's why you have to go through that system. It have, especially chlorine. Chlorine could cause, it's have a special word for it. I'll find out. But it could cause
Hemolytic
hemolysis of the blood,
yeah.
right? The blood cells, hemolysis of the red blood cells, and you can get black blood syndrome. You understand? And patients who blood is turn black and they get sick, they'll get fever and chills, or they have plenty endotoxins in water. So the reasons why you have to make sure that the water has no contaminants and no endotoxins is to avoid the patients from getting also something called endotoxemia, right? Which is endotoxins in the blood. Right? So this is why you have to have clean, you have to have purified water. Otherwise, if it water not purified, instantly all your patients is get sick, chills on the machine, fever, the pressure start to drop, they're vomiting, they're getting cramp, all kind of things have to happen. It has happened. They always have to keep it up to dialysis, they water up to dialysis standards.
So, Miss, since we drinking that water, how come it don't affect us like that? And it's
It
only
don't
when it go
affect
through.
it don't affect us like that because drinking water have a standard and dialysis water have a standard. I was mentioning that, right? So a simple thing like alum that is added in the water to cause the coagulation and the fluctuation, right? Because alum is aluminum, right? In our drinking water, aluminum. It don't have no standard for aluminum in the water. You understand? It don't have a mandatory standard. Yes, it will be at a level, but it don't have a mandatory standard. But you cannot. But remember, this dialysis patient, they don't say you can't be clean. You can't put it directly in your blood because when you understand now you all getting into dialyzers. So when you all understand how dialysis works, where the patient's blood goes into the dialyzer. So the blood is inside the dialyzer and the water goes through a proportion. It have a proportioning system in the machine. So the machine does pull a certain amount of water, right, together with a certain amount of bicarbonate and a certain amount of acid. It have a 45x system, which is for 42 parts water, 42.28 parts water, 1 point acid,
0.72.
and I think it's 1.7 or 2.78 bicarbonate or something like that, right? I'll get it check out
This
for
is
you,
now
but
1.72 for
one point
bicarbonate.
seven two and yeah, 1.72 and 42.28 or something like that, right? Don't kill me. I ain't have my book in front. Me talking off at the top of my head, right? So yeah, it's a proportioning system. So when the water pull and go into the proportioning system and it mixing with your blood. You understand? This is what washing the blood. This is how ultrafiltration taking process because the bicarbonate and the acid has certain electrolytes also. So and together with the water, it makes this mixture called dialysate, right? So you can't wash your blood with pipe water because then you're dead, right? It had too much contaminant. You could drink it from your mouth because that just going in your digestive tract and your body will fight off that because that is for your stomach. Remember, your stomach has acids and stuff like that that could fight these things. But when you just put it directly to your blood, then your whole immune system has to come and activate now, right? And that is why you will get chills and fever because when your immune system start to activate, your white blood cell count getting high. You understand? Your blood pressure start to drop low because all kind of thing happening. You could allow you can't allow aluminum inside it. You could only allow 0.01. And there is a chance that you're taking to even allow a 0.01 milligram per liter into dialysis water in with chlorine, right? You're not supposed to have no kind of chlorine in your water to dialyze your blood. If you get a cut, simple thing like this, right? If you get a cut, if you get a cut and or you see blood and you drop bleach on it, what is happening? Do you see the blood turn black? So if you're washing your blood with this and your whole blood will turn black, you can like do the experiment. Just cut yourself and drop a little drop of blood and drop a touch of bleach. And you'll see what has happened when you use bleach on blood. That's why, when you had them crime scene movie and you're watching it, you're going to kill somebody and throw bleach after, and throw hydrogen peroxide to take off all that blood stain, right? So, in case you just want to kill anybody. So, everybody understand
Yes,
why you
miss.
can't use
Yes,
normal
ma'am.
Yes.
water for dialysis? Because they have too much contaminants in global water to mix with your blood.
But miss,
And
that is going through the principle of hemodialysis with the diffusion and the
diffusion, not
solute
diffusion,
diffusion, sorry, of solute, so yeah, solute across a
solute,
semi-permeable
semi-permeable membrane.
membrane. Yeah, it's telling us about the different things. The same thing I was talking about.
Yeah. And this now you all need to learn something because this is what your next these things is what your next exam is based on. You are going and learn about the KU of the dialyzer, the coefficient of the dialyzer, stuff like that, right? So you
So
need
there's
to
a
read
next
the handout
essay
before
here.
Saturday. Excuse?
This, this one could be our next essay as well.
No, it didn't come like that. You need to
Okay.
know what is the difference with high flux to low flux dialyzer. You need to know the different types of dialyzers, right?
All right.
You need to know how the difference between parallel, high flux, low flux, hollow fiber dialyzers. You need to know
Oh,
what is
right,
these
right, right.
things. Is
The
that you
coils and things.
understand?
Yeah.
So if it had different types of dialyzer. What just no chapter here, just no.
Mr.
Um,
Bill, if I remember, one is high efficiency, which is
yeah,
medium to small, and the other one is high flux, which is there's a lot of the larger molecules. I was reading that today.
yes. So long time they used to use over dialyzers. Now we don't use over dialyzers. You understand? Um, yes, you have to learn, what is a solute, what is osmosis, what is diffusion. You all go and do sodium modeling. So any other questions? Yeah, you all have to know like so you all read up about convective transport, convection and things like that. You all know
Yeah.
what is clearance, you know? So did you all read chapter 7?
I just skimmed through it. I see all that.
Okay, so I think it's starts on
They
chapter
said to
6.
read 6 and 8.
Yes, it's 6 and 8, right? But when you send read 6 and 8, and it has chapter 7 with help also. Example, it have the semi-permeable membrane, right? So it's 6, 7, and 8. Everything goes hand in hand. And when I say read something, I mean like, yeah, read it because it's important. Everything is important, right? So if that's it, what is the different types of dialyzers? Okay, well, you're not gonna just write coil dialyzer, parallel plate dialyzer, hollow fiber dialyzer. You have to write what is a coil dialyzer. You have to write what is the parallel plate dialyzer because of the differences you need in it too. So you say coil dialyzers consist of a cellulose acetate membrane tightly wrapped around a plastic or a metal coil and encased in a rigid plastic housing, while parallel plate dialyzers are assembled in layers like a sandwich, and sheets of membranes are placed between supporting plates which have ridges, grooves, or cross hatchets to support the membrane and allow the flow of dialysate along it. And they also have the hollow fiber dialyzers, right? Which is the most commonly used all over the world, right? And because the hollow fiber dialyzer is different because it has different sizes and different membranes, you know? So you have to be able to explain this is what makes an essay, not just points. Although you have the points and you have it, you have to say, oh, what it is. You know? You all.
I
Yes,
misunderstand.
miss, understand.
So that's why, yes, read chapter 6, 7, and 8, and read all the handout that read it all before Saturday. Right? Just how long does it take to read a handout? A half an hour? If you read, did you want it?
Miss, I went through till
Let's
10.
try tomorrow.
You see? It's not bad.
Yeah, it wasn't bad. I had read most of well,
I
the
want
entire chapter 7, but
when you're reading, and when you're reading your handout and you're reading your chapter, you could make your points, right?
I had just put the pros and cons of the different types of dialyzer. I didn't go into depth with any of them though. That's the only thing.
Well, once you know it. So, anybody else need me to explain
Miss, that is the
anything?
only topic we
I don't know what topics. I ain't giving no topics this exam. Because I don't have it. I don't know. I want to see how
the
well
last
everybody
class
would
we
do.
had
From
two
my help.
topics, the water purification system and the dialyzer.
Well, if that's what you all did. But everything on the handout is going and come. I hope you all had this handout what for the week this week? Trying to open Google here. Let me see if I can get this handout. Principles of dialysis.
Yes, miss, we get that for this week.
But you all got it since before class last week, right? So you're
Last
telling
week,
me that some just came through.
last week.
Right. And
I
are
read
you
all
finished with the
this.
handout yet?
Miss, one of the handouts not printed properly and it's not showing good on the phone. But I read out the other one though.
That one, but the man,
Yes.
yeah, but the next handout that they will send, it just have this, it does have the meanings too for osmosis or whatnot.
Yeah, miss, I read all that.
Yeah, so it's basically the same thing, principles of dialysis. Okay, yes, I understand. So you see, but the handout with the man, you see how they having in the beginning define these words: solution, semi-permeable membrane, diffusion, osmosis, filtration, ultrafiltration, and convection. Bet your bottom dollar, you have to really learn that. Those three things, right? Explain how diffusion, osmosis, filtration, ultrafiltration, and convection help to remove fluid and waste during dialysis. These are things that you will need to know. So that is why it is good to read this handout, because you get majority of your answers right here. And you'll be able to explain it properly. So even you could try zooming it up, and you're getting to see the words better. So anybody else have any issues? Okay, so I guess everybody understand everything that's far. And seeing that we have a quiet class, I guess that is the end of class. Everybody has logged out.
No, miss, I here.
No, miss, I'm here.
I know Donovan and Tiwana here, always. Yeah, so guys, we'll be wrapping up now. Anybody with any concerns, going once, going twice, you all can speak now, or you all can message me, contact me. So everybody enjoy your
I good
night.
for now, Sarah.
Yes, nice to know Tiffany. Everybody enjoy your night. The 3 students that
You
has been
too.
speaking to me all class, and to the other, well, to the 7 students that spoke to me throughout the class, and to the other 30 that is online. I hope you all enjoy your night.
You too, miss.
Right?
You
Feel
too.
safe to
Thank you,
message.
miss.
Feel free to message.
Later.
Okay.